Hey y'all, what up? So we're working on module 61, which is going to be our natural logs. So we've been dealing with regular logs, right? And there's actually a second kind of log called a natural log. And you see that as ln, and the calculator button is immediately underneath. So you see the button for log, and then right underneath you see the button for natural log. So logs have a base of 10 almost all the time, right? If they don't have the number there. And the natural log's base is the letter E, right? The letter E is a number, it's roughly 2.71, and it goes along with the natural log, right? So anytime we see a natural log, we're going to have a base of E. So that's what you see here. You see this letter E. It actually doesn't stand for it doesn't stand for a variable. It's actually a number, right? So that number, 2.71, to the power of something is going to be equal to 5. The way that we do this is with the same loop, right? So that same loop. So we're going to have ln this time because we're dealing with a natural log of E. That's our first thing, our base. And then we come to our 5 next, and it's going to be equal to our answer. It's the same exact loop as we've been dealing with. In our calculators, we have been putting like log 5 over log E, right? Something like that, a change of base formula. But the cool part is that ln of E actually work together. So we can just type in our calculators the natural log of 5, just like that. It's going to spit out a number. So if you try that on your calculator, log 5, natural log 5, you should get 1.6094, right? A reminder that they want thousandth place, that's 3, 1, 2, 3. I'm going to look at that 4. The 4 doesn't change it, so I'm left with just this as my answer, 1.609. All right, let's try a second one. So we have here e to the 2x plus 1 equals 4. I want to get this e by itself, right? So I'm going to subtract that 1 right away. I get e to the 2x equals 3, right? I see that I have e here, so I'm going to use my natural log, right? So I have, I'm going to start here with my natural log of e, wrap around that 3, right? It's going to be equal to 2x, right? So in my calculator, I'm going to type ln of 3, and that's going to be equal to my 2x. From there, I'm going to type ln of 3 on my calculator. It's going to give me 1.0986, dot, 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 and it's going to be equal to 2x. I want to get x by itself, so I'm going to divide by 2 on both sides. Divide by 2. I get 0.5493 equals x. I still want thousandths, 1, 2, 3 decimal places. That 3 is not going to change it, so I get 0.549 as my answer. All right, so exactly the same process. We're just using ln instead of the log. Finally, on this last one, we saw this yesterday with different directions. They kind of change up the rules around number 70 maybe. And so they change it and they want it in simplest form, right? So in simplest form, not going to do anything crazy. I'm just going to rewrite it as e to the x equals 25, right? It just means that they don't want you to approximate it using your calculator. So if I'm looking at this, I have my loop goes like this. I have ln, the power of with the base of e, 25 was my next thing, and it equals x, right? Because ln automatically has this e, we don't have to type it, so we're just going to put ln of 25 equals x, right? That's the most simple form, so we're going to write ln of 25 in our box here and press enter. That is the natural log. Thanks, guys.